In this lesson, we're going to dive into function notation a little bit. And the reason this is useful to us, right, is notice right away I have two polynomial functions. They're both quadratics in the text here. And I can give them names, right? Which is useful specifically because they mean different things. So I would probably annotate. First of all, now would be a great time to pause and read this word problem here if you haven't already. X is shoes. R of X is revenue. And C of X is cost. So I would always annotate for what X is in a problem like this and what the functions represent, so you know what we're talking about. And then we're asked to find C of 3 and R of 3. And that just means I'm plugging 3 into both. And I just use my calculator to do that. And notice I just took out my X's and put in parentheses and a 3 for both expressions. So my top one is C, my bottom one is R, and you can type them in all in one line like that. So I would say R of 3 is 25.5, and C of 3 was 7.5. And we aren't asked for this here, but it's always good to know what we're finding, right? So R of 3 and C of 3, so notice already it's useful that they have different names. R is the revenue. So this is $25.50 in revenue, meaning how much money you make, right? For 3 pairs of shoes. And then C of 3 is $7.50 in cost for 3 pairs of shoes. And then the profit, right, this is not rocket science, and this is not new either. It would be $25.50 minus $7.50, which ends up being, what, 18 bucks? $18 in profit. And now in number C, here's where this notation gets useful, right? So we're asked now for a function p of x to represent profit. So we want now a function, not a dollar amount. So we want a formula for the profit when we sell a certain number of shoes. So notice the name of this thing is p of x. And that's going to be equal to, and I'm going to color code this for you guys, revenue, r of x, how much money you make, minus cost, C of x, how much money it costs you, right? And then the reason that I color coded this is because we are actually going to simplify this as a formula. So R of x, well, from the text, that's x squared plus 3.5x plus 6. So here's R of x. And then minus C of x. And notice, I'm going to put this in parentheses, so minus C of x, because I'm subtracting the whole thing. Right, so C of x was here in the text, 0.5x squared plus 2x minus 3. And then notice this is math you already know how to do. We're just combining like terms here. So the first thing I'm going to do is I'm going to distribute, and then I'm going to combine like terms. And I think you guys are good enough at this probably that I don't need to show the intermediate step of rewriting everything. So x squared minus 0.5x squared is 0.5x squared. And then 3.5x minus 2x is 1.5x. And then 6 minus negative 3 is a plus 9. So that's my p of x simplified, is this result here. And notice we're also asked for p of 3. So p of 3, well, that's what I get when I plug 3 into this. And make a prediction right now, what should I get? So again, I've plugged this into my calculator, replacing x with 3. And notice I get $18 again. Right, so there's two different ways to tackle this question of what is the profit for 3 pairs of shoes. This gets us an equation, a formula that we could use for any value of x. So notice like the key to this problem was subtracting two functions, and we use a certain notation for that. So we'll start with subtraction. One way we can represent subtraction in this notation is f of x minus g of x. But it's not the only way, so sometimes different notations are more or less convenient to us. So we could also say f minus g of x, and this is kind of a shorthand notation like this. These mean the same thing, so these are equivalent. And each operation sort of has these equivalent notations that it's good to be familiar with. And notice that we have our 4 kind of basic math operations here, And then we have this idea of a composition down here, which we will talk about here in a second. That's probably newer. So I'm just going to fill out this table with these equivalent notations. You need to be familiar with both, just in case they come up later in your math career. It's not that hard to tell the difference or interpret them. They mean exactly what they look like they should mean. So those are our 4 basic operations. And then a composition, this word composition means plugging one function into the other. So that looks like either f of g of x, like that, or f of g of x, like that. And that may be the idea that is least familiar to you. And we'll look at an example like that here in a second. So notice that you're given f and g in the notes here. F divided by g would be f on top, because that's what our division notation means. So x squared plus 16x plus 60 over x plus 10. And we're not quite done yet, so what we can do is I can factor this on top. So we should check to see if it will simplify. Just like if you wrote 2 over 4, it wouldn't be as good as writing 1 over 2, right? And then notice, boom, these cancel out. X plus 10 over x plus 10 is 1. And f divided by g of x is equal to x plus 10. Okay, so that's the trick here with this notation, is you should simplify when you get a chance. Now, f of g of x, I would say make a note of how you read this. And this means plug the function g into f. So we still have f of g here. I'm going to color code this one. So this would be all equal to, I'm going to write my outside function first. So that outside function is f because I'm plugging g into f. And I'm going to leave a space, squared plus 16 plus 60, right? And then that's my f function. What I'm plugging in there is g, right? And I'm going to show this step. A lot of you guys can do it in your head, but I just want it to be clear. To expand this, we need to multiply by itself, right? And this is my preferred method. It's not the only way. So I'm going to plug that back in. This is that, right? My 16 over here, I'm going to distribute. So what I get is x squared, 10x plus 10x is 20x, plus 100, plus 16x, plus 160, plus 60. And notice I still have some like terms that I can combine. So I'll bring down x squared, and then my x terms combine to 36x. And then my constants, I have 3 of them. I have 260 here, plus another 60 is 340. No, sorry, 320 I get. So that is my f of g of x. Right, so notice I plugged one into the other, and I would have gotten something completely different if the order had been switched.